What's up, YouTube? Today I'd like to talk to you about programming to exceptions. Now, this is not so much about what are exceptions and how to handle them or how to catch them. It's none of that. It certainly does encompass that sort of thing, but this topic, I call it programming to exceptions, has nothing to do with exception handling. In fact, in my opinion, the right way to handle exceptions is to not handle them. And that is what this video is about. This is a very, very big idea or a concept. It's difficult to grasp or understand, and certainly it's difficult for me to explain. It's, to me, in my mind, it's very simple. So when I explain it to people, they say, yeah, we got it, but they don't. Right? So what I'm going to tell you is pay attention to what I'm saying. Don't gloss over the stuff that you seem to know, because there are gems in all of this. And this is a big part of the Programming with Intent series that I have. The very first video itself is called Programming with Intent, Method Design. If you haven't watched that video here, please take a look at that video before you come to this one. This is the pivot around, or the hinge around which Programming with Intent hangs off of. A whole lot of ideas are based on programming to exceptions. This is a term that I have created or called it. There's no, if you went and talked to somebody about programming to exceptions, they won't necessarily know what that means. They think you're talking about exception handling, and I'm saying I don't want to handle exceptions. So to make it even more fun, I'm going to say I love exceptions. I absolutely love exceptions. I throw exceptions all the time, and I catch none. That's what programming to exceptions is all about. I'm obviously overstating this stuff. I certainly have a whole lot of exceptions in my application, custom exceptions. I throw at will any exception, anytime. And I don't catch them. All right. So as I said earlier, the right way to do exception handling is to not handle them. Of course, as I go deeper into this talk, I'm hoping I will impart the right ideas, the right concepts to you. Initially, I want to just go through some of the reasons for using exceptions. Not just using, I mean throwing exceptions. There are really good reasons to be throwing exceptions. Now, it's easy to misuse them. And I think the reason exceptions have got a bad rap typically in the community is, one, you fear exceptions. We hate to see exceptions in our applications, and I love to see them, because when I see an exception, it's mine. The difference is, if you don't write code correctly, you're going to see exceptions you don't expect. I write systems correctly, and when I see exceptions, they are ones that I threw for a damn good reason. And that's the big difference. There are a lot of ideas behind this, but I can go on and on, because as I said, it's a difficult idea to impart. It's a very simple concept for me to understand, but I understand that most people, they understand a part of it and they walk off thinking they've got it. So please pay attention nonstop, and I'll try and make this not so boring or dragging on, but everything I'm saying is really important. Well, when is it not, right? All right. So as you can see here, the purpose of this presentation is to offer the guidelines for how to program to exceptions, and when and how to use exception handling in your code. Now, if you can write code, like you're seeing on the screen here, if you can write code that has no conditional statements, that's where you want to be. I don't have conditional statements in my code. Now, when I say I don't have conditional statements, that of course there are some business rules or some classes that are handling or implementing certain rules. That class would have conditional statements, of course. But if you look at the mass of my code, if you look at the bulk of my code, I probably have conditional statements in about, depending on the complexity of the business system, of course, but generally I find that people have exceptions in places that I would never have them, right? And so I know that I have far fewer conditional statements in my system than most people do. And the reason is, I think, very simple. If you look at the methods over here, for example, register member internal, this line over here, what would happen if something went wrong in register member internal. The member would not be registered for n number of reasons. Right? In order to register a member, there are so many things that have to be in place. Here, the reason I write code like this and can write code like this is because I program to exceptions. Now, you may already be doing this sometimes, some cases, but I'm saying this needs to be done everywhere in your system. There's no ifs, thens, buts, and maybes. This idea has to be followed through in your entire system. And I'll explain why in cases where if you didn't do it that way, you should do it that way, as in this, the way I'm showing it here, because there are, of course, reasons for that. So we'll get to that in the next slides. One of the key concepts from programming with intent is this. Methods that are actions or commands, that is, methods that are actions or commands, meaning they either get you to do something, these methods claim to do something, they should not return anything. They should be void returning. So just think about this statement. If you were to, let's say, update a record in a database, and if the update failed, what do you expect? Now, I know when you are put to the test, you'll say, well, I'll throw an exception. I am betting if you went back and looked at your last 5 years of code, that's not what you do. I mean, seriously, I see this today. I see it every day today at work. Not code that I've written, but when I'm reviewing code or happen to be talking to people, this is being done all the time. Methods that are actions or commands should be void returning. You have to get in that habit. Now, this is a blanket statement. Of course, I'm sure there are anomalies, but you know what? If I told you there are anomalies, every scenario you find, you're going to say that's an anomaly. So she said there's an anomaly, so I can do it like this. No. As humans, we can rationalize our way into things or out of things. Your aim for this specific rule is to say, I'm going to make sure all my actions or command methods are void returning. I'll tell you where the anomaly exists, but first you have to sort of buy into this idea. And conversely, methods that are queries should return only the data they claim or not return at all. And this is a different idea. So in the first one, you can imagine that your method is doing something. There's no need for you to return something. Of course, it's doing something. You never asked it to get you something. So if we asked it to do something, why does it need to return anything? If you are returning an int or a bool or something, it's for you, for your sanity. You want to know if the method succeeded, isn't it? Yeah, of course, that's what you want to do. I'm saying return a void. If the method is unable to satisfy the request that you made, which is do something, it should throw an exception. Which means that you on the call side don't have to worry about whether it succeeded or not. If it didn't succeed, you don't have to worry about it. You have no code in your call side that has to handle the scenario where it could not do something. And we'll see some of that code. It's simple code, but in case you're wondering what I'm saying. The second bullet is that query should return only the data they claim to return or not return at all. If I said get customer, and we see this some code for that, I think, in the slides here. I said get customer, give it an ID, get me this customer. If the customer is not found, this method says it's going to return the customer. If the customer is not found, this method should not return at all. How do you not return at all? Exactly. Throw an exception. The call side, the method that you're calling, the one that does the query, it is saying, I'm going to either return to you a customer that you asked for, or I'm not returning. Period. There's no ifs, thens, and buts. There's no null customer. There's no some success or failure code in relation to a null customer, right? It is either returning a customer or it's not returning at all. And again, in order to pull this off, query methods would have to throw an exception. Now, as soon as I say something like this, people will say, well, but then what if I don't want an exception to be thrown because I don't know if the customer is there? Well, that's not a get. So let's distinguish between get or retrieve customer, which is really you're saying, I know this customer, just get me this customer or retrieve this customer. The other option is the search. You don't know. Okay, then don't call it get or don't call it retrieve, call it search. Now, search methods where you're searching and hoping to find something, those methods are not, they fall in the between. They're not the commands or the queries. They are some other method. But yes, that's an anomaly where you may have to return a null customer, or if you're returning a collection, then it'll be an empty collection or something, right? But that is not the normal case. Keep in mind, you have to be able to distinguish between the gets and the searches, or the retrieves and the searches. One is saying, I know it's there, please get me that. And if it's not there, it should throw an exception. Okay? So both these methods, or both these guidelines, are basically saying that methods should be throwing an exception. In the first case, if the method can't do what you asked it to do, it should throw an exception. In the second case, if the method can't get you what you asked for, it should throw an exception. All right? Both throw an exception. The first one is avoid returning. All right. So here's the code example. If a method claims to return something, then it should return that or not return at all. And if you look at the code here, it's simple code, but I'm trying to keep it simple, yet I'm hoping to impart the idea. So this method here, send order confirmation email. I'm betting most of you would have had a conditional statement that says, if I got the customer and it's not null and blah, 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 then send the order confirmation email. I'm saying don't do that. You ask this method, get customer, to get your customer with an ID of 42. If it can't find a customer with ID 42, this method, the get customer, throws an exception. That's it. You don't have to worry about it. Who's going to worry about it? Let's talk about that later. Not now. You don't have to worry about it because you have no idea what to do if you don't get a customer. What are you going to do? If I came up to you and asked you for, let's say, I want to go eat food and I'm broke as usual. So I come and ask you, hey, can you give me $10? And you say, no, what am I supposed to do? I mean, the intent was me to get money from you so I can go get some food. But if you don't have the money, then I don't get the food. I mean, I don't know what else to do. You know what I mean? It's to think that we can come up with, for every scenario, we can come up with some sort of an alternative solution is insane. Your system should be writing the code for what it knows, not what it doesn't know. And it's not supposed to be imagining all the scenarios where it doesn't know things and what am I supposed to do in those scenarios, right? It's a very simple concept. Write the code for the happy path. Don't worry about the unhappy paths. 99% of your system's code will get totally cleaned up. You simply have to write code for the happy path. Try it. Try it. You'll realize how cleaned up the code gets. Now, immediately I'm sure you're thinking, okay, if you don't catch the exception, then whose problem is it? Well, it is your problem, but not here, meaning not in this method. It is eventually, it's not a problem, it's your responsibility. Let's not call it a problem because it's not a problem. But it is your application's responsibility to do something with any exceptions that fly out. And we'll talk about there's different scenarios for that as well, depending on what your application is. Is it a service? Is it a website? Is it whatever, right? So, but it is the responsibility of your application to do something with any exceptions that fly out of your system or about to fly out of your system. But it's not the responsibility of all the code that is trying to get work done, which is the rest of the system, right? The assumption you make when you program to exceptions is this. If I got to this line, if execution got to this line, and let's say there's 20 lines here, and this is the 20th line. If execution got to this line, then all other methods prior to this method were successful. That is a huge assumption I can make if I'm programming to exceptions. It's a huge assumption, but it's a valid assumption. This idea cleans up your code drastically. So you want to program to exceptions because you want to be able to write code like this that does not have conditionals. I'm guessing some of you have written, and you can put your hand up if you want to, that you've written code like this where the second line here would say, if customer is not null, then send, or whatever the validation you think is valid. I'm saying don't do that, right? Write code like this. So there are a few reasons. I'll let you read these bullet points here on this slide, where there are reasons for why you should not return error codes or return values that indicate success or failure, or any data structure that includes or is indicative of success or of failure, right? So error codes and return codes is the same as saying I've got an object today, then one of the properties of the object tells me if there was an error or not. So that it includes all of that. So you can pause this video and you can read this whole thing, but essentially what I'm going to say for this slide is that when you are not programming to exceptions, your method is returning some value. There's nothing in the compiler that says if the caller of your method that's returning some value that includes the success failure or is the only thing is the success failure, that the caller of your method has checked what you return and that it has done the right thing. There's nothing in programming that says that there's a feature like that. Now, maybe some linters and code cleaners might say you're not using the return value, but there's nothing that actually enforces that you have to use the return value of a method because you didn't bother to check to see that method returned the success or a failure or whatever the case is. With the exceptions, you don't even have to pick and choose it, and you don't have a choice. It just blows out. But it doesn't come back to you on the next line. It blows out as it goes up the call stack. So when you called it some method that throws an exception, it is not your problem to handle that error. Let it fly out. Your code has to just go on to the next line if it succeeds, right? That's the basic idea. So these are all the reasons for why you should not be using return codes or error codes. If you want to pause this, pause it, read it, and move on. So when you program to exceptions, as the title says here, it changes all of your assumptions. Errors throw exceptions, and this translates to methods returning valid data or not returning at all. Simplifies the code such that you can reason about the flaws of code. And if you don't believe me that it simplifies your code, write it and check it out. Your code becomes so simplified, so clean, no conditionals, no indentations, just simple one line orchestration, bang, 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 bang. That's it. And again, methods either return what they state or does not return at all. A standardized way to communicate error conditions no matter what the constructor's properties, methods, in other words, no matter what it is, whether you have an exception in a constructor or setting properties, getting properties, calling methods, whatever it is, there's only one way to report or communicate errors in your system, exceptions. It's no matter what it is, you're always throwing an exception. It's not the return code over here, bool value over there, some structure that includes the return code in it somewhere else. And nobody has to know the 15 different ways in which you can return error information when there's only one standardized way to send or communicate exceptions in your system. Throw exceptions. So the APIs are consistent, and there's an idea in programming to exceptions I call fail fast and fail visibly. Fail fast means as soon as the, let's say, data enters your system, check it, clean it, and throw it off here if you don't like it. In other words, you're validating the data. And I don't mean like in a controller, essentially, but think of it this way. You're building a business system, a service application. So I'm not talking about the service part, the controllers and the web API aspects. I'm talking about the actual code that is your system, that I call what I consider my system. In that system, there's this idea of the front door and the back door. And if you've watched my video with programming with intent, I say, if you lock the front door and you lock the back door, you're safe in the house. And this is a key concept. If you lock your front door means if you've cleaned up all the data that comes into your system at the front door, at no point in time can any bad, incorrect, invalid data enter your system from the front or from the back. The back door could be database, other services you might call to get data. You ensure before that data comes back into your system from the back door, it is clean, it's valid. And if you've locked the front door and you've locked the back door, you're safe in the house. Now you can make all sorts of assumptions and clean up all sorts of code that you would probably have repeated 10, 15, 200 times in your system because you don't know if the data you're getting is correct. And when you pass that data to somebody else, they don't know if by somebody else means some other class in your system. That class doesn't trust what you just sent it. And then when it calls somebody else, that class doesn't trust. So basically you're doing the same validation n number of times in a system, right? In programming the intent, I say there's no need for methods to validate their incoming arguments. It's just that simple. If you lock the front door and you lock the back door, you're safe in the house. So as I said, these are all tied together. Programming with intent, method design, programming to exceptions. They're all part of programming with intent. And you have to kind of use all of it. You can't pick and choose the parts and pieces you like, right? Because then all kinds of weird things can happen. Okay, I'll let you read this. If you want to pause the video, please pause the video. But essentially, what I found is that, there's people who do logging. That's another topic, discussion, debate topic, logging. It's like they can't trust their system. And I never log anything. I mean, by anything, I don't mean I don't log exceptions, that not the ones that I've thrown, but the ones that happen in my system that I never expected, which are very, very rare. But they're technical in nature. And we'll talk about what that means. But if you are going to be writing code in such a way in your system that you can't trust it. And I'm thinking, every time I see this happening is because people are not programming to exceptions. They're trying to account for all the possible scenarios where the system can go wrong. And as a result, they know they're not accounted for all the scenarios. So there could be weird things happening yet on top of all the clutter they've increased in their code base. I'm saying don't write code like that. You program to the happy path. Don't worry about the exceptions path. Every method you call should throw an exception if it can't do what you asked it to do or if it can't give you what you asked for. That's it. Simple as that. Yeah, now you can go home and start programming to exceptions. I'm not done yet. Now, there are some guidelines, responsibilities, caveats that are in place when you throw exceptions, when you program to exceptions. 1, you need to write or have custom exceptions for every different scenario. You don't want to reuse exceptions. So these are exceptions that you define, and we'll talk a little bit about how that happens or how do you define that hierarchy of exceptions. But these are your exceptions. You define them. You're never using any of the .NET exceptions. You define them, give them proper type names that they signify a very specific use case. Don't make generalized exceptions, please. Every unique scenario will need an exception that you define as a custom exception. Now, maybe there are times where you might use the same exception type here and there, but that's not the same exception is occurring in different places. But every exception is very specific. It's not general. It's not generic. All right? When you throw an exception, it comes with a huge responsibility. So please, I'm saying throw exceptions anytime you don't like something. But it is totally irresponsible if you throw an exception and you don't explain the problem clearly. So when you throw an exception, there are some very strong criteria or strong prerequisites for when you throw an exception. And these are never compromised. 1, your error message should indicate clearly to the user, and imagine it to be a human, even though it may be another system, clearly to the user what happened exactly. Provide that user with any information they provided you that caused the problem. Saying, you can't just say customer username is invalid. But what is the username you got? Can you please provide me the username in the exception message so I know exactly which username you're complaining about? Okay, so you have to provide the user with a clear message indicating exactly what went wrong. You have to provide them with the information they provided you so that they can understand what exactly went wrong. By I'm just saying generally, it could be deep in the guts of your system. Whatever that method received as an argument, that has to be a part of the exception message. And 3, your message should also indicate to them possible valid values, for example. So for example, if there's an enum or you're translating something to an enum, a string, in your system is an enum. The user got sent you a string. You need to respond as part of exception message, all the possible valid values. Even if it's a true and a false, this thing needs to be a Boolean. So please send a true or a false as a string argument. If this case sensitive, make sure you indicate all of that. what I'm getting at is these three things are the criteria or prerequisites for throwing an exception. Messages should be really, really clear, explaining to the user exactly what went wrong. The message should include any information that they sent to you, even if it came in indirectly, so that they understand what might have gone wrong and therefore they can try and fix it. And 3, your exception messages, if and when possible, and it happens more often than not, please provide valid inputs, so valid values for things that you know have caused the problem, so that they know what they can send you to in order to not get the problem. All right. So that's the high level guidelines for throwing exceptions. And the messages, particularly, the types of the exceptions need to be unique and the messages need to be really, really clear. If you're throwing an exception, oh my gosh, it would piss me off if you threw exceptions that did not give me enough information. Just last week at work, I was working with one of the devs and they said, they're seeing this exception. I said, okay, what does it say? Luckily, it wasn't my system. It says not found. What's not found? Don't know. Man, it took us a day and a half to figure out what was not found. I mean, seriously? Is this how you want to design methods, systems? So don't be one of those people. You should say exactly what was not found, why it wasn't found, what I might be able to do to find that thing. Okay, so all those pieces of information need to be in the exception message. It's not okay to throw exceptions with half-assed, information in the message. Don't take shortcuts. It's not okay to have the same exception type being reused across different generalized scenarios. Okay. All right. Oh, there it is. I forgot that. So another feature or another idea from programming to exception is call us data, call us problem. This is the same as saying you don't validate the inputs to your methods, right? Why not? Because listen, I asked you for a string. You want to send me a null? Your problem. It's not my problem. I will not validate inputs to my methods. One, I've cleaned up, I've locked the front door and I've locked the back door, right? So that's a given. On top of that, and the reason I lock the front door and I lock the back door is so that I'm safe in the house, which means I don't have to validate every argument that comes into my methods, just like you wouldn't have to. Then why would I do that? And if it does occur, it's not my problem. If you call my method and you get an exception, it's your problem. You need to fix it up. I'm not going to do a thing. And please don't do that. Don't try and prevent the exception from occurring at the symptom, right? You need to fix the problem at the root, the cause of the problem, not in where the symptoms are being shown. In other words, you're seeing that my method's throwing an exception because you send me invalid data. Where do you want to fix it? My method or your method? Exactly. So in the previous slide, what I was trying to show over here is that they need to be at the right level of abstraction as well. For example, if I'm working with a database and the database server could throw an exception. Do you write stored procs with exceptions in them? No, you should be. Your stored proc should be throwing exceptions as well in the cases that make sense at the database level, right? You can sit and argue all this, but at the end of the day, that's what it should be doing. It's not implementing business rules that you would know in your system. It's implementing rules that it knows in its system, which is the database. But let's say it throws an exception. Do you want that exception to be seen outside your system? Like, do you want a database exception to be thrown out and seen outside your system? Of course not. Which means you might have to catch that exception, the DB exception, and then translate that exception into one of your exceptions and the message and throw that exception instead. Now, when you do that, please remember to use the original exception as the inner exception of your exception. Did it make sense? So I'm making an assumption that you understand exceptions. I'm not going to sit and explain to you what exceptions are. Every exception in .NET has an inner exception in the constructor argument. If you're throwing a new exception inside of a catch block because you caught the DB exception, and you want to translate it into one of your exceptions, you would have to have a catch block, and in your catch block, you're going to say throw new your exception. Please ensure you pass the original exception as the inner exception of your exception. Does that make sense? All right, cool. So you need to throw exceptions at the right level of abstraction, which also includes something like, let's say I don't know you're using a file. When I ask you to do something, I haven't a clue that you would be using a file. And then if I get an exception that says file not found, I'm thinking like, what does the file got to do with this stuff, right? Like, why would you want to confuse me when I don't even know you're using a file? I mean, let's say, I thought you're using a database, right? And you're not using a database, you're using a file system. When I say insert customer, you say file not found. I think, what file? You know what I mean? You don't want to confuse end users or systems or consuming systems with this error message that doesn't make sense. Now, you know that you're using a file system. That means something to you. Let's say, for every customer that you create in your system, you create a physical file because that's where you maintain the customer's data. As an example. So if you didn't, and I said, please get me customer 42, and you didn't find the file, you know what that means. You know that the customer doesn't exist. You can't say file not found. Like, that doesn't make sense to me. Wouldn't make sense to me, right? So you would have to translate that exception to say customer 42 not found. Because when a file is missing in your mind, in your system, you know what that means to you. I don't know what a file means to you, but I know that customer doesn't exist, what it means to me, right? So you have to translate that as well when you throw exceptions. I apologize if I'm going really fast and a bit scattered. It may sound like it's scattered and it may sound like it's fast, but I'm going really slow. But you probably speed up the thing and you're going at, twice the speed or something. It's a topic that's difficult. It's simple and difficult. I don't know how to explain it. A lot of people think they get it. They walk away from after my explanation and they immediately go and repeat the same mistake they were doing before I, found them doing it. It's just one of those things. Throw exceptions anytime you don't like something in your system. Anytime you don't like something that occurs in your system, throw an exception. I throw so many exceptions in my system. I have so many custom exceptions in my system and I throw them all over the place. Anytime I don't like, I throw an exception. I'm never trying to find ways and means not to throw exceptions, right? I asked you for this. You didn't give me that, out. I asked you for a string. You sent me a null, out. Right? I'm not trying to entertain what to do with that problem. Now, maybe some point in the system, maybe at the UI level, when you're working with the end user's input, you have to be a little more lenient, right? Because the users will make mistakes. I'm not talking about that front-end system or the JavaScript, part, the browser side, if you will, if you got a web UI. I'm talking about the system. For me, the system is not the front end of the UI. Apologize for anyone that loves UIs. I love UIs too, but when I say system, I'm talking about not the UI. The UI will receive any exceptions the system throws, and the UI will have to translate that into something more user-friendly and decide whether it should be using the same exception message it got from the services or systems, or does you have to translate that to something even simpler, or just be vague about the problem, right? Our systems are busy. Please try again, even though you had a file not found on this end, right? That's a UI thing. I'm talking about the rest of your system, right? That's what I'm talking about for the most part. So if you throw exceptions everywhere, there should be no try catches in your system. Like, don't pretend like you can catch any blooming exception I send at you. Now, if you do have a try catch, it should never be catch exception. There's only one place in the entire system where you should see a try catch, and we'll get to that. We should never have a try catch for the most part in your system, so that the problem doesn't arise to start with. But if you do have a try catch, like I was talking about the translating of exceptions for the database or the file system thing earlier, yeah, of course you'd have a try catch. You're catching a specific exception. Don't catch general exception type. Catch a specific exception type. And if it's something else, you don't even know what to do with that. If it's out of memory, if it's Stack Overflow or whatever else happens, how would you know what to do with it? So don't pretend or don't claim to be able to handle any and all exceptions. You don't know how to do that. So don't take it upon yourself to do that part of the job either. Let it fly out of the system. That's the beauty of exceptions. Use the exceptions for what they truly are. Beauty. Beautiful. Okay. In .NET, we have the tester doer pattern, which is the try something, try parse, or try get, those kinds of things. Those are the ones you want to use at the user input, user input layer, meaning that the UI, the C# side of the UI, let's say of an MVC application, you can't assume that the user, when they pass to you int is going to translate an int because it came to you as a string, right? And then you just see if it can be parsed, and only then can you set it to be an int, an actual int. So if it's not an int, you might want to do a tryparse rather than throwing an exception. There's an idea that's called, some people call it, do not use exceptions for control flow. There's only one book I've read that actually explains that concept correctly, right? It's Dr. Bob Martin's book called Clean Code. Most of the people think every time you throw an exception, you're using exceptions for control flow. Yes, damn it, that's what exceptions are for. What do you want me to use them for? And some choice words in my head right now. If I don't use exceptions to control the flow, what is the point? That is the point of exceptions, right? They just boot right out. They just go up the call stack. Nobody has to be worried about handling them, except for something or someone or one thing in your system. Exception for control flow is when you know something is going to happen. And I don't mean like the exceptional scenario. That's the... When you throw exceptions, when there's an exceptional scenario. What? What's an exceptional scenario? Something that's exceptional. I don't know who comes up with these terms in software, but if you don't know enough, don't try and explain it. Right? Or speak clearly. If you know it in your head, you should be able to speak it and explain it clearly. Right? However, this topic is difficult. When you throw an exception, anytime something happens that you don't like, that you're not expecting, you throw an exception. Period. To you, it's not about exceptional scenarios. It's not meeting your requirement. You don't know what to do if you don't get this. Right? Throw an exception. It's always exceptional. Going back to do not use exception for control flow. The way people typically do it or misuse it is they call a method, let's say, and this method is going to throw an exception. And if it throws an exception, then the result is, and this is unfortunate, but as an example, let's say the method that you're in is returning a true false to indicate success failure. Don't do that. That's when this gets used. So the idea is if it succeeds, you return a true. If it throws an exception in the catch block, you return a false. Have you seen that code? I've seen plenty of it. And if you're a Java programmer that's moved to .NET, that's what you're doing. Java has its own issues. Won't talk about that. But most Java programmers, not all, most Java programmers that I have ever met and worked with do not understand exceptions. That's not their fault. Their language doesn't have a clue what to do with exceptions. Long story. Won't go there. But can you picture the code? Try, do something, catch, and in the catch you say return false. And if the do something succeeds in the try, you return a true. That is using exceptions for control flow. You are letting an exception occur, and if it occurs, you'll return a false. If it doesn't occur, you return a true. That is not the point of this. So that in those cases, you should be using the tested doer pattern, right? The tryparse int or try int.tryparse and double.tryparse and datetime.tryparse and so on. Because those are scenarios that are user input scenarios are very likely to be incorrect. Now, talking about user problem scenario, let's talk about login. If you have a login method, should you throw an exception if the login fails, or should you return a bool? Login is a method. It's a do, it's a command. Throw a goddamn exception if the user cannot log in correctly. Yes, it happens frequently. So what? It's not an exceptional scenario. That's what I'm saying. It's not about exception scenarios or exceptional cases. No, it's nothing to do with that. Yes, users could mistype the username and password. Maybe you have some validation step to ensure that the username and password itself is valid. Remember that? Lock the front door thing. If you lock the front door and you lock the back door, you're safe in the house. By the time you get into the login screen, I'm guessing you've passed the front door. Right. So for the case of a login, throw an exception if the user does not succeed, if the login doesn't succeed. You don't want to complicate your code anywhere, right? But When you're using exceptions, like when you know things are going to fail, like a user input, right? Now let's say the customer, get 42. If I had to return a bool there, first of all, this bad method design to return a bool and to check if a customer exists when the method says get customer or customer exists, and the way you're doing the customer exists is you're calling this the store proc, and then you're calling the other method that said get customer. That method returns an exception. So you would say, okay, then I already have the method that gets me the customer 42, right? So I'm just going to catch it here. And if it throws an exception, I'll return a false. In other words, sometimes my mind works faster than my mouth does. You have two methods in your system: get customer with given an ID, and another one that says, does customer exist? It's very easy to say, I've already got the get customer method, but it throws an exception if it can't find one. So I can use that from the if does customer exist method, catch that exception and return a false if it does, and return a true if it doesn't. That is using exceptions for control flow, right? You don't want to do that. You want to have a separate method that potentially goes to the database to see if a customer, is there, and if it's not there, it returns a true or a false and so on, right? You don't want to use the other method that throws an exception to do what you want to do over here. I hope that got across to you. If you didn't understand the programming to exception, so don't use exceptions for control flow piece, please write me a comment. I'll try and explain it, or send you some code or something. All right. So this is about the exceptions and performance. A lot of people say, but exceptions are slow. I don't really care. How slow? What are you building exactly? You're building some system that flies at lightning speed? Of course not. Heck, you would be using C#. Anyone that claims to be using C# to make a high performance system, think again. Yeah, now in C++, there are many cases where we will not allow throwing exceptions. And in fact, there are keywords in C++ that says no except. That's saying this method is guaranteeing that it will never throw an exception. C++ is at a different level. And even in those cases, they did a survey recently. I think it was 50-50. 50% of the code base in C# does not allow exceptions, meaning they're building systems that cannot afford to be slowed down or don't have the infrastructure. Remember, exceptions are part of the operating system. So if you're working on an embedded system, you don't have that infrastructure for exceptions. So you can't have exceptions there. Then there are, of course, systems in C++ that are trying to squeeze out as much performance as possible, and they don't want you to throw exceptions. In C#, there's no such case. Again, if you're not misusing exceptions, you should never have a problem with throwing exceptions. So please don't get caught up in this whole thing about performance. Your system sucks already. I can tell you, if I did the code review for system, I'd probably guarantee to increase the performance of that system by 40%. Exceptions are not a problem. Everything else is. Now, to be serious, don't not use exceptions because somebody tells you they're slow. There are 10 other ways to get the performance of your system back. And you can continue to throw exceptions and your system will still be faster. Trust me. All right. So, my custom exception slide is to be filled in. So do you mind filling that slide in so I can talk about it? Okay, the idea is, I'm hoping, very simple. For every application that you start, you need to have a base exception. And I'll show you some hierarchies. A base exception in actual code. There needs to be a base exception for your application by that name. So let's say your application is called My App. Then there will be an exception base class for your app called My App base exception, not exception base, because the convention says all exceptions should end in the word exception. This application will be called My App. My App is whatever the name of the app is, base exception. So that's the root tree, right? So there's the exception class in .NET, and then your exception descends from the .NET's root exception. Now here, this is your app. From here on in, there'll be a branch. One is for technical exceptions. The other is for business exceptions. I'll get into the details of what that is. So then there'll be a my app technical base exception and my app business base exception. And after that, the entire line of exceptions here, the third level, is this broad hierarchy, not deep, but broad hierarchy from that point forward, where you design or define all of your exceptions that descend from those exceptions. All right. So if you want to see some code here, let me show you some code. I'll have to find the code. Okay. So these are all the custom exceptions in this application. And somewhere in here, you're going to find the Ooblex base exception. So this is the base exception for the application. The application is called Ooblex, and that's the Ooblex base exception. And then hanging off that, you have the business exception, Ooblex business exception that descends from Ooblex base exception, and the Ooblex technical exception that descends from the Ooblex base exception. And after that, all of the exceptions that you see here are all descendants of those two exceptions, the technical base and the business base, right? So what's the technical exception? Okay, what's the business exception? Any exception that you throw of your own accord because something was not working as per your requirement. You have bunches of requirements, right? When you lock that front door, you're validating things. And things don't work out correctly. Those are requirements that were not met by the caller of your application, the user, or another system. Anytime you throw an exception, you have to think about, is this a business or a technical exception? By technical, it means it's not your, business exceptions are not your problem. They're causing your system a problem, but they're not your problem to fix. The caller typically has to fix it, right? That's a business exception. Technical exceptions are things that you might have to fix. Let's say you misconfigured your configuration file and you've got some bad data in there and your system is blowing up. That's a technical problem. Can't reach your database, that's a technical exception, and so on and so forth. Right? So the technical exceptions won't fix by themselves. Typically, you have to go in and make a change to the code or to the file or something has to be modified for a technical exception, typically, to get sorted out. Business exceptions are typically things that you throw. They're always things that you throw, exceptions that you throw for reasons that you don't agree with something that's happening in your system. It's not the system threw an exception, you are throwing an exception, but you're throwing an exception because there are business reasons for why you're throwing an exception. Something is not correct. The date is not correct. The range of dates is not correct. What are the cases? You throw an exception every single time something happens in your system that you don't like. Fail fast and fail visibly, meaning throw an exception. Don't hide the problem, right? Your configuration system, if you haven't seen the configuration provider video and the exceptions and what that's supposed to be doing, please take a look at that video over here. It's important. That's your backdoor. Your configuration system is your backdoor. You need to lock the backdoor. Right? So take a look at that video and see how you're supposed to build configuration providers in your system as well. Now, there's lots to cover here with regards to exceptions and programming. I'll show you some code now, some code that you might, just generally to show you how things look. So here is my manager class. It does a lot of work, but you can see there's no conditional statements here. Yeah? It's like simple stuff. It's not simple, by the way. It's very complicated stuff that's happening here. Don't get confused or fooled by the simplicity of the code you're seeing. Simple is not easy. To make code that is doing complicated stuff look simple, that's what you should be focusing on. So for example, registered member, this of course was being called by the public method here. That's a lot of stuff going on here. It's calling databases, it's sending off emails, it's doing a bunch of things. And every step there are validations, but you don't see that here. That's the whole point, right? It's just simple, bang, 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 bang. Every method is just doing orchestration. And that's the beauty. These are doers, right? These are commands. Register member. It's not saying get member. Now let's look at the gets. Get member with username. Okay. Let me ask you this. This is a get. It's a query. Query methods should either return what they say they're going to return or not return at all, right? If you give an invalid username for whatever reason, let's say usernames can't be longer than this or shorter than that, or whatever the case may be, also null. If it's invalid username in some form or fashion, you would need to throw an exception, right? Because you can't even bother to try and get the username. You're never going to find one. So step one, just validate the username. Is the username valid as per your requirement? And the ensure is going to throw an exception. If there's anything wrong with regards to the structure or formatting of the username or whatever the case is, it's going to throw an exception. There's no if, throw. If you don't like it, throw. If you like it, it's going to come to the next line, which means the username is now valid. You can go get the username. Now, the database might say, well, I didn't find this user. But it's not the database's job to say, if it didn't find a user, it doesn't know what you're trying to do with that, right? So you have to let the user come back, and the user happens to be null. This ensure member was found will throw an exception again. So in other words, you're returning a member only if you can. If you can't return a member, you're throwing an exception. The caller of this method will thank you for it. Believe me, they will thank you for it. Might get them a bit of time to get used to this idea as well, programming to exceptions, but they will thank you for it eventually. So that's what code looks like in my systems. At least they're very simple. The methods look very simple. There's nothing simple about this. I'm going to show you some other method with regards to catching exceptions. In my systems, let's say I'm building a web API application or a web application, MVC or web API application. Then there's only one place in which I have a catch block for the most part, just one place. And that is at the entry, the very first point in my system, what I call the entry point. In a web API application, it is with .NET Core and ASP.NET, you could use middleware. So I've got this middleware application, middleware class, and here is the one and only try catch in the entire system. This entire system will have this one try catch. It catches exceptions. This is the anomaly. This is the only place you will catch exception because you don't know what the exception is. And pretty much the purpose here is, this is a service application, web API application. It has to translate. And if you haven't watched my roles and responsibilities of a controller and the other video on middleware, please take a look at that here. I won't go into the details of that, but that's why this is over here. So most of my applications have a single try catch. I don't mean is exactly one, but it's in that entry point. So if let's say there are 10 methods and we don't have middleware, then each of those methods, the entry point of your systems will have a try catch because they are invariably translating that exception to something else, some other format like HTTP or something, right? But nowhere else in the system will have a try catch. Now, there could be in the translation case. So let me show you that scenario. Let's say here, so in this case, for example, I have a try catch because I'm rolling back the transaction, but I'm immediately rethrowing the exception. And so I'm not saying I know how to handle the problem. I said, I don't know what the problem is. I don't care what the problem is. I'm going to have to roll back the transaction and then rethrow the exception, right? So that's as I have a try catch, but I'm not swallowing the exception. I'm not logging. I'm not doing anything, right? So when I say there's only one place in which where I have a try catch, I mean that when I'm doing something with the exception or about the exception, right? In this case, I got to start a transaction, and then if all goes okay, I commit the transaction. But if something goes wrong, I have to roll back the transaction, right? And then I rethrow the exception. I don't swallow it or pretend it didn't occur. Then there's the cases where I'm doing that translation of exceptions. Let me see if I can find something like that here. I guess not. This is too deep in my system it's not trying to translate the exception. So I might have to look elsewhere. But you understand what I'm saying. It's a database exception and I don't want that database exception flying out of my system. So it'll translate that exception. So of course I'm going to have to have a try catch for that scenario as well, right? All right. Man, this was super speed, but I'm hoping, you guys are finding this interesting. If I missed something, if I haven't explained myself to you, please write me a comment. Tell me what it is that I missed or didn't explain clearly, and I'll try and explain that to you. If it warrants me making a whole other video because I missed something really massive or important, I might just do that, but nonetheless. And I appreciate your time. Please subscribe if you haven't already subscribed. Please hit the notify button if you haven't already notified. For some reason, I have more views from non-subscribers. I don't know if YouTube has got a bug in their thing or not, but there's it's about probably 60 or 70% are non-subscribers. So if you haven't subscribed, please subscribe. And thank you for your time and watching these videos. And I will see you next time.